So an inequality is a math sentence that compares quantities. That may be super obvious now, but these four symbols are four that you need to be very acquainted with, and you should be pretty well acquainted with the first two on the left, less than or greater than specifically. In word problems, you may see it as fewer than, or is more than, or exceeds. But again, we'll get to the word problems in a different section. But then we end up with these types, like this one right here, right? But then it's got the line underneath it, which it may look like some kind of hieroglyphic or some foreign language, perhaps. But it has the less than symbol, but instead of just writing two lines, remember what I've told you about math people were super lazy. We didn't want to write two lines for the equal part of that, so we just wrote one. And then we was like, well, that looks kind of cool. Like, you could write that in stone and people would think it's Stone Age. But, yeah, that would be less than or equal to. And we're going to talk about that more here in a second. And so this one also greater than or equal to. So, well, yeah, I guess let's talk about it right now. Let's look at this what's going on? This inequality. Again, it's just comparing these two values. And if I said, well, 5 is less than 6, hopefully you'd be like, yeah, that's true, man. That is truth, and that's good. We like some truth. But if I said, well, 1 plus 5 is less than 6, well, you think a little bit, and you say, well, that's just 6. And then we have to ask ourselves, is 6 less than 6? And the answer to that is no. Now it's a false statement. But the moment we put the equal part on that, now it is true. All right? So it's important to be able to distinguish between the two, because when we get equalities, which we will, and we're going to treat these almost exactly like we would equalities, it's important to remember that in some cases where that line doesn't exist there, it's no longer a true statement. But it does tell us where the inequality transitions from truth to falsefulness, I don't know. All right, so I'm just going to translate these. I'm not going to solve them yet, but like number 1 here, it says Bob's earnings at $10 per hour are more than $150. All right, so I would write it like this. I'm comparing it with $150, and it's $10 per hour, right? So 10, I would multiply it by X, and I'd say X is representing the number of hours that Bob works. But it says it's no more than $150, right? So it's no more means it could be equal to, but it definitely couldn't be greater than. So in any case, the 150 could be more than the $10 per hour, but it could also be equal to. And of course, some of you guys are like, well, I know that'd be 15 hours, and that's fine. So in other words, Bob had to work at most 15 hours to make that statement, the original statement, true. So the next one, a price decreased by $5. So X, we'll say, is the price. It's been decreased by $5. It's now less than. So this is a pretty direct translation. It's now less than. Oh, that's $80. There we go. So this would be the translation of that sentence into this inequality. But again, and some of you guys again did the price on that. It was $85. Some price decreased by 5. The maximum price is just under $85, right? So if I said X was 85 in this case, it would not make that statement true, right? Whereas in the first question, if I said X was 15 in that one, it would make the statement true because it includes the equal part of that. All right, so again, it's pretty crucial to remember that stuff, especially once we start graphing these inequalities. When you're given an inequality, you can check and see if it's true. It's just like checking to see if an equation is true. That's true. Check the value that would make the inequality equal. This is a good way of checking your answers, which is a very good practice. when we're looking at equations and inequalities for that matter. I guess I'm going to expand on this, but I would say that top part there isn't really completely important yet. I think it will be very important in 1010 though. So if I just looked at a number, right? I think we looked at 5 earlier, and I said, how many numbers are less than 5? Now some of you guys would look at that and think, well, there's 5 numbers less than 5, right? 0, 1, 2, 3, and 4. And that's true, but is there more than just those values that are less than 5? And hopefully you think for a little bit and be like, well, yeah, there's all the decimals as well in between those numbers. And then we can ask, how many numbers are there between the numbers? And hopefully you'd realize pretty quickly that there's an infinite numbers between all numbers, as it turns out. But then we would also think, well, yeah, you also got negatives, right? If I said, what number is less than 5? Yeah, you'd go all the way into the negatives, and there's an infinite number of those as well. So when we talk about inequalities like this, and this is what I'm talking about, this is x is less than 5. Again, a solution to this needs to make that statement true. And the fact is there's an infinite number of values of x now that will make this true. And so in order, we're not going to count all of them because it would take so long. And again, only one person's ever counted to infinity, which is ginormous. It was Chuck Norris. But we have to show this using an inequality that there's just so many answers that we can't even demonstrate it. So x is less than 5. Now, we're going to be showing it graphically as well on just a straight number line like this. But I'm not going to show it right here yet. We'll get to that. But then, in addition to that, there's going to be a third way that you're going to be asked to show this. It's called interval notation, which we're going to get more into. So, again, this is just kind of hammering the point home. We're just looking to see if these values of s, k, and z, I guess, would make these specific inequalities true. So it's just like regular evaluation, right? Like we got s minus 17 is greater than 5, and we're going to say we're going to replace that s with 14, right? Now when I do, I just want to see if it's true, so I'm going to put a question mark right there. Oh, 7, yeah, thank you. There we go, thank you. And yeah, well, 14 minus 7, that changed it completely, is 7. Well, 7, this says that 7 is less than 5, and 7 is not less than 5, you guys. And look, you guys, if you're like, I remember back in elementary school that they'd be like, I'm going to draw some teeth on that guy, and we'll give him a body and some eyeballs and a tail, and things were pretty happy back in those days. But does it? Oh, thank you. Well, I appreciate I appreciate the kind words. Yeah, well, that's in elementary there's like, hey, there's a good alligator, and they'd give you a hug in elementary and you felt good about it. Just please don't do that, because we're in college, you guys, all right? Like, if you're gonna draw an alligator like that, please put some wings on that sucker and really go the extra mile. Like, we got to demonstrate that we're at a higher level, right? So give him some wings. It's like a bat alligator. What the heck? Let's go and tack on shark fin on that sucker, and we'll call him shark alligator bat. Well, shalagat. I like shalagat. That sounds good. I don't know how you're gonna escape that thing, because well, a shalagat. It's a shalagat. I don't know how you escape those guys, because they can fly, they can run fast, and they can swim. So good luck. I feel like I got off on a tangent there, but I also feel like it was important. Like, we're in college now. So next up, we got number 2 here. And, again, we're just checking for truthfulness at this point. So we got 5 times k. It's greater than 35. But we're going to replace the k with the 7 right there. So, yeah, here we go. Take that, make it 7. 5 times 7 is 35. It's a question mark there, yeah. Well, then we got to ask ourselves, self, is 35 greater than 35? And hopefully we know the answer to that is no, so this one's false. I forgot to put false on that first one. I got caught up in my shalligat. So that one's false. Now the next one, it's the same inequality, but some of you guys noticed it's got that greater than or equal to part of it. So yeah, we'll replace the z with 7 on this one. And yeah, sure enough, 5 times 7 is 35 again, just like we thought it would be. But again, we got to ask ourselves, is 35 greater than or equal to 35? Now, it's not greater than 35, but it only needs to be one or the other, which is why it is an or statement. And that's important for you guys to remember. That's coming back at us. It's only got to be one or the other, and now, since it is equal, it is also true. Or this is how you would go about seeing if the values you got after you've solved it would make the original true. And it will be kind of important. But we're going to show you techniques where you don't necessarily need to check it this way. What we're going to be doing really is just checking for equality in these ones. Alright, so solving any inequalities, right? It's a different symbol, but you guys hopefully will notice that it looks almost exactly like an equality, right? And as it turns out, that's how we're going to treat it. 5x minus 8 equals negative 23. Now, the reason why I'm using equality is because where the values are equal is where the inequality will transition from being true to being false. All right? That may not make a lot of sense yet, but I hope I can demonstrate it by the time we finish this. So I'm treating it like an equality because that's where it transitions from truth to false. So I'm just going to solve this like a regular equation. I'm going to add 8 to both sides of the equal sign to zero that out and isolate my x's. Right? There was no distribution, no combining like terms. So I got 5x equals negative 15. And now what I would do to solve this is I'd divide both sides by 5 to make that 1x. So I got x equals negative 3 now, but now I will look back and remember that I was dealing with a greater than symbol, so I'll just drop it down here. Now there is one other point of analysis that I should do, and you should do every time you solve these, is just to see if you ever use the principle of equality, of multiplication or division, where you use negatives. Now I use the division principle of equality right here with the divide by 5s, right? But the 5s were positive, which means it doesn't change anything. And it wouldn't matter which side you chose for the x's on this either, which will be important to remember. So x is greater than negative 3, which means that if I go back to the original inequality and I replace the x with negative 3, it would be false because it would give me an equal statement. But the moment that I go anywhere or use any number that's greater than negative 3, such as 0 or negative 2.99999, it would then give me a true statement, right? Which means if I checked on the other side of negative 3, such as negative 3.0000001, it would remain false. Because again, I need a value of x that's greater than negative 3. Alright, so we can also graph inequalities on a number line. It helps you visualize what numbers make the inequality true. So that last problem that we just did, where x is greater than negative 3, I'm going to write that so I don't forget it. That's demonstrating to everyone that there's an infinite number of values that would have made the original inequality true, just like there's an infinite number of values of x that would make this inequality true as well. But like it says there, we could also demonstrate all the values that are greater than negative 3 with a number line. Okay. So I'll read through this first, right? Less than or greater than have open circles, and greater than or equal to and less than or equal to have closed circles. And be careful with this next part. Some students are like, well, the inequality will tell me which direction to point the arrow, which is, it's only true if you keep the x's on the left, which sometimes is not always the best option, or most convenient, I should say. So this is the way that I do it. If it eats the x, and yes, I'm talking about the shalligat, if it eats the x then the line is going to go to the right of that circle, whether it's open or closed. If it does not eat the x, or the letter, then the line will go to the left of that circle. Now, if you're doing it by hand, you should use 3 numbers. I always like to see where 0 is in relation to these values. So, I mean, on this one, I'm going to use 4, right? That's where -3 would be, right there. So, just evaluating that last problem that we did, x is greater than -3. At -3, because that's where it's equal, that would show an equality, the equal portion. It's just, in this case, it's that greater than symbol, right? So I'm just going to use an open circle. Now the open circle, I mean, not that everyone should do this, but you know, as you get more experience with this, that communicates to people that are reading this that the value of -3 is not included in the solution set, which means that -3 would make the original statement false. Now, just like it says up there, the inequality is eating the x, so the line should go to the right. So that purple line, all the values, I'm going to say underneath it. When you guys graph it on the homework, it would just be over the line. But all the values underneath the purple line right there would make the original inequality, and this one we have, x is greater than -3, would make it true. And then we put an arrow on that line to indicate that it goes on forever and ever and ever. Now, just so you guys understand, on the homework, when you do this, you're gonna have to do 2 things. You're gonna have to click on the option for the open circle and then put the circle right there. And then you got to click on the option to create the line. And to do that, for me, I always click on the value on the number line. So for me, it would be -3, and then I drag it all the way to the side until it shows me an arrow. If it doesn't show the arrow, then it doesn't think you want to go all the way to, in this case, positive infinity. So just keep that in mind when you guys are doing the homework on this stuff. So looking at these, we'll graph them real quick. It's all pretty much the same comparison, right? X and 4, we're comparing them. We're just comparing with different inequalities. So on this first one, what is that? Yeah, number 1 at 4. I'm going to say 4 is right there. It's an open circle because it's not equal and it's not eating the x, so it goes to the left. Okay, and another thing we should remember, especially with these number lines horizontally, is if we look to the left on the number line, those are values that are getting smaller and smaller or less and less. And yes, I'm using less on purpose because it says x is less than 4. So when we look at 4, it needs to be all the values that are to the left of 4. And then number 2, I don't know what happened to 3, but number 2 at 4, again an open circle, but this one eats the x. So we're looking at all the values greater than 4, which are to the right of 4. Now number 4, which for some reason is not number 3, at 4, it's a circle, but I'm going to close it in like this. Okay, and again, if I was reading this, I would know that you meant to show that 4 is part of the solution set. It would make the original inequality true, and then it's not eating the x, so it goes to the left. There's our arrow to the left. And then this last one, I'm going to say that's 4 right there. Again, I'm going to close it up because it has this equal part. It is eating the x, so it's all the values greater than 4 and equal to 4, so it goes to the right. Okay. Now again, some of you guys are looking at this and noticing a little pattern. It's like, well, the inequality points the direction of the line. Well, that's true until you switch the side of the x, right? So on number 2, that's the exact same inequality. It's still eating the x, but you definitely would not drag that line to the left of that purple circle because it's eating the x, because it's now 4 needs to be less than that, all the values of 4x. Okay. We'll be using those principles all throughout this this unit, because all we're going to be doing is inequalities, pretty much, right? So on this one, we're going to solve it. We're going to solve it, and then we're going to graph it. So again, we're going to treat it like it would just regular as an equation. So I'm not even worried about which way that's eating until I get to the end. And so I'm going to subtract 9 from both sides here to zero that out. So I'm going to drop my x over 2. Oh, that's a 2. There we go. And again, I'm using equal here because I don't really care about which way the inequality is eating. And then I'm going to get rid of that divide by 2 by multiplying both sides by 2, which is going to make that a phantom 1. So now I get x, and I'm comparing this with what is negative 8. Now going back, it was greater than or equal to, but again, I go to my principles of equality, and at this, in the purple stage here, I multiplied both sides by 2, but 2 is positive, so I don't need to worry about changing the inequality. And I may have not said it already, but if you ever multiply or divide both sides by a negative, that means that you have to flip the inequality, okay? Because the negative thing is going to make it be opposite, okay? But again, in purple here, we multiplied by a positive 2. So even though I was multiplying by a negative here in red, it's more that I multiplied both sides by the positive 2, which means that the inequality stays the same. So now that I have that, let's do the graph actually. Now I said if you're doing it by hand, you don't have to do it by hand on the homework, but I'm going to do it by hand here. In the past, our tests were written, so you had to do it by hand. Remember, especially when you're looking at negatives, if you go to the left of negatives, it's going to be more negative, right? Because sometimes in the past, especially when we did written tests, a student would get these two mixed up, the negative 9 and negative 7. They put them on the wrong side of negative 8, so keep that in mind. But just following what we went over, the x is showing that it could be equal to negative 8, so I need a closed circle there at negative 8. And then again, I look, it's eating the x, which means that the line should go to the right here. So all the values to the right of negative 8 and also negative 8 would make that original inequality true. All right, so I'm gonna fly through this one just because I want to get to one of those that's gonna actually flip the inequality for us. Or you know what, you guys want me to make it a negative 2? That would do it. You guys want me to do it? So I'm going to work with the negative, and again, I'm not concerned about the inequality. Now I can work with it though, right? Like you guys said, if you wanted to bring that down, that's fine, because the subtraction principle of equality is not going to change that at all. So I zeroed out that positive 8, and I got negative 2x is greater than 4 and 4 is a 16 right there. And then I'll divide both sides by negative 2. And again, I just divided both sides by a negative. Now, right now in my brain, the alarms are going off, right? Because I haven't changed it yet. They don't always either. Sometimes I miss it. But since I divided both sides by this negative here, it does flip the inequality to be, instead of greater than, now it is less than. So that's a 1x right there. That's good. And 16 divided by negative 2 is negative 8. Oh, it's another negative 8 problem. Whatever. So there's my inequality. And I could check for truthfulness for equality on that, just to make sure that I solved that correctly, which I would still recommend. But the other thing you should do, like if you're not sure, it's like, you know what, I know it's an open circle at negative 8, but I don't know which way the line goes. All right, now remember, it's an infinite number of solutions, so if you check anything to the right of negative 8, it should make the original inequality true. Or if you check to the left of negative 8 and you're looking for truthfulness, then it should make it true. If it's false, then the line just goes in the other direction. And again, that may not make a ton of sense, but you guys will explore that more in 10.10. So again, for me, I would say, go. Yeah, I've got the x. It's not eating the x, right? So I know that it's got to go to the left. If it were eating the x, then that green arrow would go to the right. So this is the graph right here. And again, on the homework, you won't have to be doing it by hand. You'd have to put the circle there at negative 8 and then drag that line to the left. Keep the same. So solving this one, we'll graph it. Graph the solution set. It's not asking for interval notation, which I'm kind of surprised at, but I'm sure we'll see it. So again, this is a one-stepper, which is great. We like these one-steppers. It's just when I'm going straight into division, right, on both sides. But again, I've divided both sides by a negative, which means I need to flip the inequality. It was less than, now it flips to greater than. And then, yeah, it's a 1W equals, that's going to be positive 13. So W is greater than 13 would make the original inequality true. So we'll go to the graph on this one. It's not too bad. These are positives. So, be careful on those. Sorry, that's not very proportional. Open circle at 13. It is eating the W, so it goes to the right. Bam, we're good. So the first thing I would do on this one is isolate my K's in this case. And no distribution, no combining like terms. Just isolate the K's. So I'm going to zero out that negative 14 by adding 4. All right, yeah, add 14. That's better. Well, that does zero that out. This will give us a new 27 right there. Still got 10K greater than or equal to 27. And then, of course, still the same, just like we talked about before. Divide by 10 there, making that 1K. And dividing by positive is not going to flip that inequality. So I'm going to keep it as an improper fraction as well, you guys. Okay. This one didn't say you had to solve with a graph. And there, if I remember right, there are some questions on the homework that do not require the graph as well. So I'm going to keep it like this, okay? So if I had to graph this by hand, and you are welcome to use the decimal, especially since it's divided by 10. It's not too bad, like 2.7, right? But if I were to graph this myself by hand, I would put that number in the middle, the 27 tenths. Since it's positive, I just go up 1, 28 tenths. And I know that fraction can be simplified, but I think even this one is the 26 tenths. But it's not really necessary that you do when you're using a number like this, especially by hand, because showing that it's in tenths and then how many of them we have, I think it's a good practice. So I would just keep these fractions unsimplified like this, and also as improper fractions. So at the 27 tenths, close circle, it's eating the K, so the line goes to the right. All right, let's try this one here. This one doesn't look too bad. So, principles of equality, we'll subtract 4 from both sides. And I think, yeah, that's correct. That zeroes out the 4 there, so now I got 3x is greater than or equal to 12. And again, we're going to divide both sides by a positive, so it's not going to flip the inequality. Just x is greater than or equal to 4, which we've seen already. We've actually already graphed that inequality, but we didn't do the number line by hand. So I got 3, 4, 5 on my number line. I got a closed circle at 4, so that's where it transitions from truthfulness to falsefulness, and this line goes to the right. And again, we see that transition. I don't know if I've emphasized this well enough yet, but 4, anything to the left is false, and everything to the right is true, where the 4 would have made the inequality equal. And again, since it is 4 would make the original inequality true, we just color in that circle notation. So interval notation, it's just the range of values that makes it true, it's kind of a different way to show the graph. At least for me it is. Like when I think about interval notation, I also think about the graph. So I use the graph to write interval notation. The only thing you got to remember is that there's 2 sets of parentheses, okay? And we use regular parentheses like this when it says the value's not a solution. That means that you're using either less than or just less than or just greater than. We use these square brackets here below if it were a closed dot on the graph, which means you'd be looking at less than or equal to or greater than or equal to. So when we see those symbols, we need to know which of the 2 sets of parentheses or brackets we're using. So again, less than or greater than, regular parentheses. When it's equal to, then we use the bracket to indicate that the value that we're showing would also make it true. All right, so on this one, right, I said I'd use the graph, or I use the graphs, to write this inequality or interval notation stuff. Now the interval is pretty much all the green stuff that I have on this graph right here. So I know it starts at 4. I'll use green again. I know it starts at 4, and it goes all the way to infinity, right? So this is kind of like the boundaries of the graph. Starts at 4, goes to positive infinity. Now the 4, we got to think, well, is it included? Well, yeah, for that one it was, I think it was this one, right? So since the 4 is included, since it was an equal part of the inequality, I use that square bracket. Now it's just a comma between the two values because it's the range of values that make the inequality true. But infinity cannot be included because, as it turns out, it's so big that it's actually always changing. And we will show the interval notation. And again, I'm going to use the graph. It didn't say the graph, but I'm going to use it so that we can. So yeah, solving this. I don't know why it's number 1. That's not 1.8. Ignore that 1. So I'll isolate the x's rather, by subtracting the 8. There we go. So yeah, subtract 8 from both sides. Gives me 7x is greater than or equal to negative 42. Continuing the principles of equality. And again, I am dividing, so at least maybe some flag should be going up in your brain on that one. But I divided both sides by a positive, so it's not flipping that inequality, okay? So I get x is greater than or equal to negative 6. So I put negative 6 in the middle just because I'm doing it by hand. To the right would be a greater value, such as negative 5. And to the left, negative 7. I just like the two numbers immediately around it. And at negative 6, we're going to have a closed circle because it's equal to the negative 6. And it is eating the x, so it goes to the right. Now again, it didn't ask for the graph, but again, I like to see the graph so I can kind of visualize what the inequality is going to look like. So the graph, it starts at negative 6, which is where that closed circle is. So I got my negative 6 right there. It's included, so I'm going to bracket that thing in, and then how far to the right does this thing go? It goes to infinity. And again, we never include infinity in the set, which is why we use a parentheses right there. So that would be the interval notation for the solutions to this inequality. Gotta get rid of that garbage. It's not 2.4, it's just 4. All right, so get rid of that. So treating it just like an equality, right? I'm gonna distribute the 4 there. 4 times x is 4x. 4 times negative 2 is negative 8. And then we didn't really touch the rest of that inequality. Now this is where, again, if you do it in such a way that the x's are always on the left, then the inequality will point the direction of the arrow on the graph. And it's just, and in this case, it's going to give us a positive coefficient, which is why I am actually going to do this the other way. And I know you guys are going to hate it. Please forgive me. You should get the same answer either way, is what I'm saying. So I'm going to put the x's on the right and the numbers on the left on purpose. It's not to be a jerk, though. It's just to make a point, all right? So I know you guys think I'm a jerk, but that's a different story. So I've got the 4x. It's on the wrong side, so I'm going to zero that out by subtracting 4x, which gives us negative 1x there, right? That zeroes that out, negative 8. I know some of you guys would do this in one step, but I'm going to do it in 2 because it doesn't matter. And then I'll subtract the 5 from both sides. There we go. Which does zero that out. So I need the space where that stinking line is. Negative 13 now is less than negative 1x. And again, I've only used addition and subtraction, well, subtraction really, principle of equality. So it doesn't flip the inequality. But now that I'm at the point where I need to divide, and yes, this is another good reason to put it on the right side, is because now the coefficient is negative. Dividing by negative is going to flip that inequality, and now I got positive 13 is greater than x. Now even if you put the x's on the right side, if you were like, you know what, I like the x's on the left, but I liked working with the x's on the right. Look, it's the same thing as writing this as x is less than 13. See how it's still eating the 13, whether you use the purple or the orange one right here? It means they're the same. They're showing the exact same, they're communicating the exact same solutions to this problem. So it wouldn't matter if you then changed it over so that you could use that idea of the inequality will point in the direction of the arrow, all right? So again, I'm doing it by hand. Not that you guys have to, but that's fun. So at 13, I'll use red. It's an open circle because it's not equal to 13. And it's not eating the x either, in either case, either for purple or orange, so it goes to the left. And again, this didn't ask for the graph, but the graph again should help us to visualize what the inequality is. Now, if I said, well, where does this inequality start as far to the left as we can go? That's negative infinity, guys. And again, since it's an infinite value, we use a parentheses on that, on the side of that. And then where does it stop going to the right? It stops at 13. And again, we see 13 is not included, so it's another set of parentheses there. And again, if we had closed in that circle, then we would have used a square bracket in blue there. But that's the interval right there. Yeah, some of you guys notice that negative coefficient of x right now, even before we start this thing. It says we'll solve it, graph it, we'll do interval notation, which there is some of those on the homework, where you need all three of them, right? So we'll start off by getting rid of that 10, negative 10. Just zero it out, add 10 to both sides there. And so that does zero it out. We'll drop the negative 6x. That does not affect the inequality, so it's still less than or equal to, and 8 plus 10 is 18. And again, now we've encountered a negative coefficient of x, and we do need to divide both sides by that negative in order to get the coefficient to be 1x. But we did divide both sides by the negative, so we've got to flip that inequality. So now it's x is greater than or equal to 18 divided by negative 6, which is negative 3. So that's the inequality. That's that first part right here. Next, we'll go ahead and do the graph. And, well, I'll do the numbers above because I ran out of space there. Negative 3 in the middle for me. To the right would be negative 2. And to the left, a bigger negative because it's smaller, negative 4. And negative 3, yeah, it's included. So I'm going to close in that circle. It's eating the x, so it goes to the right. And then finally, the interval notation, which again, I'm using the graph visually to answer the interval, show the solutions as an interval. So as far to the left as this red line goes, it starts to the left at negative 3. Now it's a closed circle, so it's included. So I have to use a square bracket like this. And then the comma just indicates that it starts at negative 3. Where does it end? Going to the right. For us, it's going to end at infinity. And again, whenever you use infinity, it's never actually included in the set. So that would be the interval right there. Now, whether you guys like the interval or not, I can't tell. I kind of assume you guys hate it, but it's just three different ways, yeah, to show that there's an infinite number of values to make it true. Let's get started on this one then. So, got to do a distribution now. I mean, that's not a big problem because we've done it before with the equations, right? Now, I would look at this as negative 1. Some of you guys like, I would just change the signs on the inside. Same thing, right? Negative 1 times positive 7x is negative 7x. And negative 1 times negative 6 is positive 6. Now, whether you like the inequality there or not, keep it or just make it an equal sign. It's not going to matter. But I do need to distribute the 4 as well. So 4 times 3x would give us 12x's, and 4 groups of negative 4 would give us negative 16. And then, yeah, don't forget that minus 2 at the tail end of that. All right, well, there is even a need for combining like terms now, right? Negative 16 and negative 2, and that gives us negative 18. So now the inequality shows negative 7x plus 6 is less than or equal to 12x minus 18. So now we get to choose the side for the x's, and this is where it's like, oh, if you're going to put the x's on the left all the time, you will end up with negative coefficients, which is okay. All right. If I were doing this problem, though, I would keep the x's on the left. So I'm going to leave it to you guys. What do you want me to do here? X's on the left or right? Let's do it. X is on the left. So that means I got to get rid of that plus 6 right there. So I'll zero that out. I'll subtract 6 from both sides. So zero that out. And again, I'm doing it in 2 steps. You don't have to, but you can. Right? Again, that doesn't change the inequality there. And negative 18 minus 6 is negative 24. So now I'll zero out the 12x there because it's on the wrong side of our inequality. And negative 7x minus 12 is negative 19x. I feel like I made a mistake, but I don't see any yet. Yet being the key word. So I got negative 19x is less than or equal to negative 24. Now we'll divide both sides by negative 19. And yeah, we just divided both sides by a negative, which means that we do need to flip that inequality. So I am going to flip it right now before I forget, which does happen from time to time. It's 1x. X is greater than or equal to 24/19. So that is the reduced fraction in the form a over b. Oh, there we go. Now, if I remember right, a question like this on the homework, you would this would be a box right here. Then you got to choose which one it is, and then you type the fraction in right here. But again, I like to see the graph, which will then kind of communicate what the interval notation is for me. So you guys like the x's on the left? Let's keep it that way. So I'm going to keep the x's on the left. I'll do this one in one step though, okay? So I'm going to get rid of the 45 right now. Right, so I'll subtract 45 from both sides to zero that out. But I'm also going to get rid of the 10x on both sides. Right, and that's going to zero that out. It just takes out one of the steps for us. Again, if you like to do that in two steps, that's fine. It'll give you the same answer, but I got negative 15x now is greater than 30. Oh, that's pretty good. And when I divide both sides by the negative 15 now to make that 1x, yeah, we divided both sides by a negative, so it flips that inequality. X is now less than negative 2. So that's the inequality part of it. It didn't really ask for it. It wants the interval, but I'd like to see what the interval would look like with the number line. So, yeah, negative 2, negative 1, and negative 3 here. It's an open circle at negative 2. It's not eating the x, so it goes to the left. So there's my graph, even though it didn't ask for it, which is now going to help me to write out the interval notation. So how far to the left does that green line go? It goes all the way to negative infinity. It's so big we can't even include it in the set. And it stops at negative 2, which also is not included. So again, another set of parentheses. And this, only the bottom part right here is what you would type in into the homework. Now, when you guys are typing in infinity, if you just type in a double O, not the number, the letter, double O, it should pull that up for you, or you can use the math quill to pull up the box, which will then allow you to just choose it from that list. Okay, so yeah, some distribution on this one. That's not bad. Negative 4 times x is negative 4x's, and negative 4 times negative 7 would be positive 28. So again, that comes out as plus 28. Plus 5 is less than 3x plus 6. I'm trying to make it small so I can have enough space to use that graph. Combine the two like terms, 28 and 5 is going to make that positive 33. So yeah, negative 4x plus 33 is now less than 3x plus 6. And yeah, once again, you guys like those x's on the left, so I'm going to keep them there. Numbers are going to be on the right side. So I'm going to do this in one step again, just to save us some time and space on this. I'll get rid of that positive 33 to subtract it from both sides. That zeroes that out. And 6 minus 33 is negative 27 there. And also the 3x, I got to zero that out, so subtract 3x from both sides there. To make negative 7x. Still less than, though. Finally, we'll divide both sides by the negative 7 to make that 1x. And yeah, that's going to flip that inequality to be now greater than. So x is now greater than positive 27/7. Yeah, that feels like I may have made a mistake there, but again, that's okay. I'm going to use that number line. I know it's going to get a little sloppy in here, but 27/7. It said reduced fraction. Oh, we just wanted the inequality. That's why. But I'm going to do the interval notation just for the sake of practice, okay? So there's our number line again, and it would be an open circle at 27/7. It's eating the x, though, so it goes to the right. And that means that our inequality starts at 27/7. It's an open circle. It's not included, so it's a parentheses there, and it goes all the way to infinity, which also not included. Now, I did that extra work where I didn't have to, but this is the real answer. It wanted x is greater than 27/7. So this would have been the actual answer.